Hello everyone, and welcome to the Central Force Pre-Lab. So we're going to start this out with a little demo. Now in class I might be swinging an eraser around my head on the end of a string, but here's a little video from my backyard, I believe in around March of 2020. So here we go, watch the video. So here you can see me whirling this bucket in essentially a circle, and as close as possible, let's watch that again, as close as possible at a constant speed, right? So here's a bucket moving in a circle at a constant speed. That is basically what we're going to be studying in this unit. Things moving in circles at constant speeds, and we're going to be looking at how to describe that motion, as well as how to, the reasons why that motion occurs, right, as we often have done in past units. So, want to start out by looking at the speed of that bucket, and what kind of things do you think I could have changed that might have affected the speed of that bucket, and again, the constant speed of that bucket? Well, several things I could have changed. First off, maybe I change the length of the string that I'm using, right? Which would change what about the circle that it spun in, right? Well, the length of the string would be the radius of the circle, right? So I could change the radius of the circle it was moving in. Maybe I could change the bucket. I could put something in the bucket, take something out of the bucket, use a different bucket, right? Which would change the mass, right, that's being swung around. And then the last one is the hardest one, usually. A lot of times people will say, I'll ask them like, well, what if I wanted to spin it faster or slower? What would I do? And people are often have a little hard time understanding that, well, whirl your hand a little slower or faster. Well, yes, but what does that actually do to the string and then to the bucket? Right? And basically that means that if you think about spinning something, if you want to spin it faster, wouldn't you have to pull more on the string, which would pull more on the bucket, right? So force, right, is our last variable. This is a big lab because it's got 4 variables. This is our first 4 variable lab, right? And we are going to work this inside of Pivot Interactives because they have a really nice way to control everything, which I'll show you in a little bit, okay? So the purpose of this lab is to create graphical and mathematical representations of the relationship between our variables, the force, the radius, the mass, and the speed of an object moving in a circle at a constant speed. Whether that be a bucket on the end of a string, or an eraser on the end of a string, or a car driving in a circle, or maybe a planet orbiting the sun, or a satellite orbiting our Earth, or any kind of examples you can think of something moving in a circle at a constant speed. Okay? So first off, I want to talk about this constant speed. Okay, because if you can imagine inside of a lab, whether that be in class or in a pivot, measuring speed is going to be a little difficult. So we have to remember here that this is a constant speed. And because it's a constant speed, we can calculate it by just taking a distance it moves and dividing it by the time it takes. Right? No big kinematic equations or anything because it's a constant speed. Okay? So, let's think about the bucket going around once. Okay? All the way around the circle once. What distance would it cover? Well, in other words, what's the distance around a circle? It's, of course, the circumference. Now, the time to go around once is a special time. And because it's a special time, it's got its own name. Okay? It's known as period. It is denoted in an equation by a capital T. You might remember that all along, all year long, if we've had a time in an equation, we've used a lowercase t. This is why, because capital T has a specific name. It's the period, it's the time for one complete cycle. In this case, one complete time around, right, is the period. We did a lab very first couple days of class for the circumference of a circle. That's, of course, 2 pi times the radius. So if we know the radius, we can calculate the circumference, divide by the period, and get the speed for an object moving in a circle at a constant speed. And again, this is for constant speeds. Okay? So this is an equation we're going to use a lot in this lab in order to calculate the speed the object is moving at, but it's also one that allows us to find the speed of something, in problems later on in the unit, right? So it'll pop up here and there, but it's used a lot in this lab. Okay? Now, in the Pivot Interactive, which I'm going to show you in a moment, we can control the speed. We can pick videos that have different speeds. We can pick videos that have different radii. We can pick videos that are spinning different masses. And then it's going to measure or allow us to see on a scale, okay, the force. And I'll show you the pivot here in a second. So force is going to be our dependent variable. Speed, radius, and mass will be our independent variables. Now, little lab theory here. If we have 3 independent variables, how many should we change at a time? Yes, only 1, right? If we're going to try to figure out what effect they have, we can't change more than one thing. So that means we're going to need to do 3 experiments. Change the speed, keep radius and mass constant. Change the radius, keep speed and mass constant. Change the mass, keep speed and radius constant. Right? So we're going to have to be very careful when we're doing these labs, and the Pivot organizes this really nice for us, so that we're only changing 1 variable at a time and we can measure things. And along the way, we're going to want to keep track of those constants, but we can do all those things inside of the Pivot. So here's a little clip of the Pivot. I'm going to run it, and I'm going to show you a couple things about it. But first off, notice we've got a mass at the end of a string. Okay? The string goes around this pulley up to a little string that's attached to a spring scale. Okay, you can't see the spring, it's behind it, but this is like, the scale that you see in a grocery store in the produce section or something, right? This scale, notice, is in newtons, right? It's in newtons. You have to be a little careful because depending on which part of the lab we're using, sometimes they're scaled differently. Okay, this one, the big hash mark here is 0.2 newtons, and since there's 10 of these in between, each one is only 0.02 newtons as we go. But there will be other scales, right, that we'll have to look at, so be a little careful with the calibration as you work through this lab. There's a little swivel mount here, as you'll see, which works really well. Everything turns, right, on this disc. There's really very little friction here between this and the surface because they're nice surfaces. Okay, and we're going to be able to measure everything on here. All right, so let me run this and explain a couple of things. Okay, here we go. So notice down at the bottom, right, you hit the change, and that's going to give you a whole bunch of choices. Here's a key thing. See those little independent boxes? So you're going to click for whichever one is your independent variable. First lab we're going to do is mass. When you click that, it makes all of these available, but only some of the others. So you select one, it locks things down. You select another, and then you hit load. Okay, you got to select a mass. You'll be able to do each different mass. You have to hit load in order to load up that video. Okay? Now, we hit play, and you'll see this thing moving in a circle at a constant speed. Right? And you'll see here that the force is now, you can read the force on the scale. Again, be careful of calibration. Now, a couple things we can do here. We can open up a ruler. Notice that it zeroes the ruler right on the string, which is right in the center of the circle. So if we move the mass to one side or the other, either the far right or the far left, we can read the radius. I'm going to play with this a little bit here to try to get it perfect. And they're trying to make nice numbers here for radii, by the way. So they intend for this to be essentially 30 centimeters, which is 0.30 meters. We got to list everything in meters. Okay? And you can get rid of that once you know the radius. Turn on the stopwatch. There's lots of different ways to figure out the period. I like to try to put the mass in the front of it, centered on the string, because the string is right in the center. And remember, you can go frame by frame here, so you can probably get pretty close to being centered on the string. 0, the stopwatch, and then run one time around. Okay, and then figure out again, so it's right in the center. And then this is the period. Notice how it's a nice number. They should be nice numbers, okay? The real nice lab setup here. So that period is 2 seconds. Make sense? Okay, how you can figure out the period then and the radius. All right, and the mass, of course, is just given to you. Right, the mass is given to you depending on which one you choose. Okay, so radius with the horizontal ruler, period by using the stopwatch, and again, all these instructions are on your lab sheet. And then the force is just read off of the spring scale, being careful of calibration. Right, it'll be in newtons. Period in seconds. Mass, by the way, if you could convert to kilograms, like it says on your lab sheet, because we're using newtons here. Right, and radius in meters. We need everything in our base units, right? Meters, seconds, kilograms, and then the force will be in newtons. Okay. Again, there are extensive instructions on your lab sheet as well as in the Pivot Interactive of how to do each third of the lab, right? There are 3 parts to this lab. I assume this is going to take us today plus tomorrow as well, probably, to get through this. So take your time, be precise with the measurements, especially with the period, and reading the radius and the force from the scale. They tried to make the numbers nice here, so keep that in mind, right? By the way, if you get in between 2 of these hash marks, which you're going to be able to see a little better if you push this button and blow it up so that it fills the whole screen, right? Then estimate in between, right? You can do that. Like in this case, every one of these is 0.02, so in between these would be another 0.01. So say in between this one and this one, this is 0.02, this is 0.04, so in between would be 0.03. Right? Estimate. Makes your data better. Eventually, you have to take your slopes and things after you graph and linearize if need be and all of that and put them into the Google form. If the Google form doesn't take them, well, then something's wrong. Call me over and we'll fix your problems. So work steadily here on this pivot and work carefully as well.